Today we're going to talk about this, the Eagle Tree Systems Vector Autopilot. Now, if you don't know, the Vector has been an autopilot that's been around for quite a long time, specifically designed for drones and fixed-wing applications. However, this is ending and Eagle Tree Systems are actually closing down. Last night on my second channel, we did a dedicated live stream taking a close look at the Vector, looking at its hardware and talking around the fact that this will soon no longer be available. Now, the rest of this video is actually taken from that live stream last night. I've actually downloaded it from the second channel and I've decided to upload it here because I do feel it's quite a lot of interesting info that hopefully you guys will find interesting. Now, if you don't know, I do have a second dedicated channel for live streaming. Every Sunday night in the UK, 10 PM British summertime, 9 PM GMT or 5 PM Eastern Time, I go live where we talk around electronics and drone related subjects. I also do random live streams as well in the week, and then if I feel the content's interesting enough, I bring it over to here, the main channel. Now, if you're interested, please do check out that channel. There is a link to it in the description of this video. I would appreciate it if you'd subscribe to both this channel and that one as well, and don't forget to hit the little bell and you'll get notifications when any new videos are released. Anyway, let's get on with this video. As I have said, the rest of this was recorded live. Please do take that into account. I do apologize for the quality in advance. Unfortunately, I've had to download it from YouTube, which limits it to 720p. In future, I will do a local copy. That way I won't have those quality issues. Anyway, let's get on with the rest of this video. Tonight, I want to talk about the Eagle Tree Vector. And really about Eagle Tree Systems, because there was some news this week for those who haven't seen, which is that they're going to cease trading. And whilst it's very easy for people to think it's just another flight controller, there are some quite major differences between what Eagle Tree are doing and pretty much everyone else in the industry. And I'm going to talk about that. And actually, the more I've looked at this, the more it's a subject I wish I'd have done before now. Now, I don't know the reasons they're finishing up. I don't know why they're stopping. However, there are some decisions that they've made along the way and they've done on things that perhaps might have contributed to it. But what I want to do is give the Vector a bit of a last hurrah, because it is a fantastic flight controller and it does things differently to everyone else for a reason. They've chosen, obviously, but that's what we're going to do. Now, just to share the laptop screen a minute, if you guys don't know, Eagle Tree Systems have obviously announced that after 18 years, they're going to stop trading. They are closing. They're going to continue to take orders via their web shop for in-stock items through September. Warranty service will continue for an extra month beyond that. But basically, they are shutting up shop. Now, it is a massive shame because they've made a lot of really good gear. I pop myself up in the corner so you can see me. You know, it isn't just about the Vector. They made an awful lot of interesting products for FPV. You know, you had their e-logger, their wireless telemetry, their micro sensors, and there was a lot of stuff for aircraft and fixed-wing aircraft especially. The Guardian stabilizer was a very, very popular device. Again, lots of gear that people who used it were very big fans of, and those who'd used the systems really got into it. But the systems weren't perfect. The autopilots had some limitations as well. And one of the big limitations of these systems has been that you could not really integrate them with other stuff. Now, tonight we're going to concentrate on these three. We're going to concentrate on the Vector and the GPS. Now, the original Vector, which is this one here, has been out now for quite a long time. And one of the big interesting things about the Vector is the fact that it had a full built-in color OSD as standard. Now, whilst we have seen the likes of Betaflight and others do that, These guys did it first, and they did it way before anyone else. There were also some really interesting features on the autopilot. The fact you could turn the camera on and off. You could turn the VTX on and off via the autopilot. So there was inbuilt switching. It had things like UART. It had audio as well. So not only would it do video, but it would do audio too. So there were a lot of really interesting features on this autopilot that many of the others didn't have, and much earlier, I should say, than the others even got close to doing it. Now, later on, they then brought out the micro vector, which was this one here. And again, this was basically a smaller version of the vector, pretty much all of the same features out of the box, but it would still hook up with much of Eagle Tree systems. You could still use it. You still had the color OSD. You still had the audio features, and it was still capable of doing everything that you would expect it to do. Now, the Vector really has been designed for use with fixed wing and small drones. And when I say small, if I remember, they used to give a limit of up to about 600mm or 500mm frame. I can't remember exactly what it was over the top of my head. And whilst many people would go larger on a quad, Eagle Tree themselves didn't recommend it. Probably because their software wasn't tuned for it. For fixed wing, though, it was really straightforward. Now, one thing to set out on the stall on this system is it is not Ardupilot based. It is not PX4 based. It is not like any of the other systems out there. And there is one main reason for this. And what we will do is we will dive in closer and have a look. 1 second. Now, if we take a look at pretty much every other autopilot out there, whether it be a Pixhawk Cube, like this, the original Pixhawk, the NASA from DJI, something like this, which was the P2 Pro. There's a reason it's out of its packet, because that's it there, because we're going to take a closer look. And all of these products shared one major thing in common, and that was the processor type. They are all using ARM-based processors, most of them using STM32F4s, especially in the early days. Then we've gone to F7 and H7s, as I've covered in other videos as well. However, the Vector is different, and this is one of the big differences, and Mark has jumped into it. The Vector is using a PIC, and it is not ARM-based at all. It is completely separate from any of the others. Now, if you take all of the other flight controllers out there, all of the Betaflight stuff, all of the Clean Flight stuff, the Naze 32, all of these autopilots were ARM-based. The whole industry has built upon that. However, Eagle Tree did it different. So, if we get in a little bit closer and have a look at one of these. This is the P2 Pro. Now, this is basically a Pixhawk, okay, is the easiest term to use for it. As you can see, this is an STM32F407, and it is pretty much a standard reference design for an autopilot. It really is. You've got your ARM SoC. You've got your IMU sensor down here. We've got voltage regulation. We've got a little bit of I/O, but that is it. And the big thing about these autopilots is the fact that everything is handled by the STM32. It's one of the big reasons the autopilot industry moved over to it. And it is the fact that there's very little external I/O and hardware required. And if you go down if you look over the autopilot, it's very basic, you know, and they're all the same. You know, yes, there's other hardware on board, but what you basically have is the STM32. You have your baro sensor, which is just down here. No, oh, sorry, that's a crystal. Sorry, the baro sensor is just here. I missed the holes. We've got our IMU, our voltage regulation, and 2 chips. And that is literally it. That's all that's in it. And all of these are the same, whether it be the NASA. I'm not going to strip the cube, but, you know, it's whilst there's a lot of other stuff in there, the basics are they're all using the STM32. However, what Eagletree did differently, and I've seen some comments, Sasha, Bill Pierre uses PIC-based mix. Yeah, again, there's one or two who did. Now, the big difference with the Eagletree is what they used, and they used PIC. Now, it is a PIC32, so if we pop them up there a minute, and we hop in a little bit closer, you will see we have what looks like, you know, any other normal SoC, but it is a PIC32. And the actual model on the original Vector, on the first Vector, is a PIC32 MX695F512L, to be precise, just to get that out there. And it is an 80 megs CPU. Now, if we compare that to what we've seen on the Pixhawks and the clones and all of these, for instance, you know, it's basically half the speed. It's only running at 80 megs. It has 512K of storage, 256 or 128 of K, depending on the model. One of the big downsides, though, to using PIC is that it's a very different animal altogether, and there are some benefits over the PIC compared to the ARM, and there are benefits the other way. One of the biggest benefits on the ARM is all of the I/O, and whilst PIC does have it, to get a lot of the functionality you would need, you have to go down this road. And as you can see, there is a second large SoC at the back, and this is actually a PIC DSP, and it is a separate digital signal processor, and it's handling all the I/O of the autopilot. And what you'll notice, first of all, if you compare it to this, is the sheer amount of hardware on board, say, the Vector, compared to this, which is basically a Pixhawk. You know, we both have our SoC. We both have our IMU, and this is using an MPU 6000, and that's the IMU for it there. Let me just grab a screwdriver. It's easier to use than my finger. So that's the IMU here. We have a crystal. We have a small I/O device, and then we have our PIC DSP. Now, it's very hard to show you guys the part number on this. I'm not sure I'm going to be able to do it. No, he's probably not going to show up. But what we have is our PIC DSP, and this is what they're using for all of the I/O. Now, if we take that, for instance, all of the I/O on that is handled by the STM32, whereas on this, it's all handled via that IC there. There's then a digital multiplexing IC here, and you've got some additional ICs for handling the I/O, the audio, the video, etc., etc. But the big difference between these devices is the amount of hardware on board to be able to just make it work. Now, the Microvector actually had an upgrade. It's not using the same SoC as the original one, and I'll decase the original one for you guys. Let me just hop him out. Believe it or not, I've been in this about 4 times today. Okay, so if we take the original Vector, you'll see that all of the basics are the same. This time it's using smaller crystals rather than using these large standard kind crystals. They're using smaller surface mount ones. The original Vector is using the 80 megs processor. The Microvector is actually using an upgraded version, and that's using the PIC32 MX470, which is actually running at 120 megs. So it's actually a faster chip on the Microvector than it was the Vector. Again, we have our IMU, and if we flip it over, you still have your DSP, our MUX chips over here, and then all of the other hardware. And the one thing to really notice about all of these autopilots is the sheer amount of hardware that is needed for it to function. For instance, that IC here, for instance, is a ROM chip. because that's where all of the firmware is stored. It's not stored on the main Pix. It's actually stored on a separate ROM chip over here. On this one, I think it's probably located on the other side. Yeah, it's one of the three here, so I suspect it's that one there. Haven't looked at the numbers on it, but I suspect it is that one there. But it's just the amount of hardware on this compared to the Pixhawk. And this is where the costs were coming from when we are talking the price of the Vector versus the other equipment. Now, if we start talking about the price of the SoCs, for instance, just to bring you back up, the Pix32 is about $5-6. That's what the cost of that SoC is on its own. If I compare that to the STM32F4, they're actually about $12. They're about twice the cost. However, you've then got to add in all of the additional hardware cost on these boards that you don't have on the Pixhawk-based system. So the real interesting thing with the Vector was, whilst it looked just like another autopilot, which was just more expensive, the reality has been it is completely different. It really, really is. And it isn't comparable in many ways to those autopilots or not. Now, the reality is they all did the same thing. You know, at the end of the day, this design has borne out, let's just say, and you could argue that this is PC and this is Mac in many ways. And it's quite a nice analogy for this, because we have a hardware design here which pretty much most autopilots will run on with a tweak. Okay, there's some changes on pinouts and I/O and things like that, but for the most part, we have an autopilot where everything will work. And now we have their custom hardware and custom software that work together to produce a solution. And again, so what you have is very much PC versus Mac, and that is where we ended up. Now, I've used the Vectors on many aircraft. Funny enough, this has only just been torn out of my Bixler for me doing the build I was doing the other day, which is the CUAV build. So I've used the autopilot, the Vector, for many, many years. I've been a big fan of it. They have a real nice bit of software, and we're going to plug it in a minute. We'll plug it in and have a bit of reminiscent on it and have a look. And it really has been a very, very good autopilot. But part of the problem here has been the fact that you have an industry growing with loads of cheap autopilots, loads of free software. You know, if we take into account what you have is, we have a mass of board reference designs, the Pixhawk standard, the boards that are all being made to work with Betaflight, and then you've got free software. So for the hardware manufacturers, all they have to do is follow a specification and make their board work. For those who were using Vector, EagleTree have not only created their own hardware design, but they're then writing the software to go with that. And that's what you were paying for when it came to a Vector. You weren't paying just for the hardware. You were paying for a custom autopilot solution. And it really was custom. You know, this isn't just another Pixhawk copy, another Ardupilot ripoff, PX4 ripoff. You know, they genuinely were doing their own thing. And unfortunately, though, the market has not beat that out properly. So it's been very hard for them to get people to understand why this board costs 3 times as much as a cheap autopilot off Banggood, and why you should pay for it, because you're not only paying for that board, you're paying for their software and their expertise as well. And that is the big thing with the Vector. And it is a massive shame it's ending. For me, it is a real shame. And it's going to end a custom autopilot that really did do things a little bit differently to everyone else. And it isn't perfect, and I'll talk a bit more about that after I have a sip of tea. And there were some downsides to this system as well, and some of those downsides may have played along for the reason they're ending trading. But at the end of the day, what you had here was a genuinely unique system that was done from the ground up. Let's have a look. Do you want to say it's because they went autopilot route and everyone else copied autopilot PX? Yeah, Gary, exactly. And correct. Sorry. So, Sasha, I used that the predecessor 10 years ago. So the pick predecessor, Sash, I assume. I'm a Mac. Remember the ads Apple run? Yeah, exactly. So, you know, that is the interesting thing. Yeah, I think it's an interesting point, Type, and this, you know, Type's comment is, I'll put it up. You know, you can't, at the end of the day, you can't really sell 3 times higher price except you if you are portioned for a Lamborghini Ferrari. And I think that's the problem in this industry. What you were paying for here was a total custom solution. The issue is that everyone was giving their software away. And that really has been the problem here. Because at the end of the day, for Eagle Tree to develop, they're not only having to develop hardware, they developed software to go alongside that hardware. And I think they really did struggle to get that message out there. And all people were seeing was $20, £20, £25 autopilots on eBay and Banggood. And I think that's where their problem has been. And the reality is, some people are going to fall to the wayside as a result of this open hardware standard. Now, that's not to say there can't be premium hardware. You know, the Cube is a classic example of that. The Cube is a classic example of how you can make premium, and I'm not going to say industrial, it's not industrial, but it's still premium compared to, say, the $20 autopilots and things like that. But you need to have something to be able to sell that off. So, for instance, the Cube is really well integrated into industry, agencies, all sorts of people using the Cube because it's built up a very good reputation. I think the problem was this autopilot, the Vector, the Micro Vector, was being sold to the same crowd as the people who are buying the cheap autopilots for the most part. Now, I don't mean the FPV dedicated crowd. I am talking about the fixed wing crowd primarily, because that's where this aircraft was autopilot was very much pushed for. And I think the problem is with the likes of Inav, with the likes of Ardupilot, it's basically ended it for them. And it's very hard for them to make money when you're trying to compete with someone who is able to knock out a board for $25 and not have to worry about the software. And I think that's the problem. Catching up on the comments. Mr. Shady, good evening. How are you doing? It is a reboxing. It is. The thing is, versus low end, the flight controllers, the Vector was a stunner. Let's face it. Built an OSD, Pixhawk. Yeah, you know, and in its day, it was a stunner. It absolutely was. And there's part of this reason is it's failed as well, actually, Mark, and I'll talk about that. Every 2 weeks, a new Betaflight firmware from Bill PA. I haven't seen this autopilot. Good evening, Bobo. How are you doing? Welcome. Bobdo, sorry. Bobbo. I'll get there in a minute. Most of the assets. Yeah. And this is about Mass Effect and these waypoints mission opens. Yeah, they did add some stuff along the way. Now, one of the big issues, I'm going to take another sip of my tea before it goes cold. It's going cold already. One of the big issues with the Vector is its lack of compatibility with other systems. So, for instance, if we take a look, we do have all sorts of IOs on this. Let's get the lid for that one there as well. So you do have a UART. You know, and if you look down, you've got your motors, your motor M2, 1, 2, 3, 4. You've got your audio, video, your USB, your bus, your UART. And whilst there was all this stuff, unfortunately, it wasn't compatible with off-shelf hardware. It all had to be used with Eagle Tree systems. So, for instance, the GPS. The GPS was their own GPS, and this is the V2. I've got a V1 and a V2 actually. And whilst it was a very nice and small GPS, it wasn't the greatest sensitivity, but also it was quite expensive as well. And you were paying, I'm sure it was like £100. I paid for one, on £80-90. Now, what we are going to do is we'll hop into this one. I've never been into this one. I actually have one I have opened before, but we will we'll hop into this one a little bit as well. This one is brand new. This one has never flown. Let me just get into him without, I don't want to damage him because it could be worth something now. Let me just get a blade on him. 2 seconds. Here we go. Okay. So, what we have is their own unique GPS. Let me just grab the nozzle. I'm just trying to find my nozzle one. It's disappeared. Oh, it's over there. Okay, so just to give you a size idea, this is the GPS off a NASA. And this is a here 2, in fact, that one is. So just to give you an idea of the actual shape and size. And yes, you know, one of the big problems was it was their own ecosystem, and it meant you all had to buy their own hardware. Now, if I just look, I can't remember how much it was. Now, they did make up to a version 4 GPS, I believe. Mine was the version 2. Product note found. I'm just trying to see how much it was. Here we go. Oh, 60 quid. You could get it for 60 quid. Well, it's not terrible, to be fair. A good GPS should be more than that. Now, if we hop him out, here too has a very big antenna. It has a massive ground plane, especially massive ground plane on the here too. It was very carefully tuned that way as well. Now, obviously, if we look inside, we have their unique GPS, and again we have another pick, I think it is, on there. I'm trying to see. Yep. So we have another pick microcontroller on board. We have our backup battery. We have our small circuit. We have our compass. There will be our compass IC. I would guess it's that one. I don't think it's that one. And then we've got the small GPS antenna on the top. So again, it was it very much again was their own hardware. Very nicely made though as well. You know, when you do look at their hardware, it was very well put together overall. It really was. The board design is very nice. The overall hardware was good. The overall board quality was very good as well. So overall, you know, it was a good system, but it was unique, and that was part of the problem. So you weren't easily able to expand it at all. You know, you just weren't able to hook it up to any other equipment out there. And whilst there isn't a lot you would want to hook it up to, there was no MSP, there was no Mavlink, and they were the two big issues. Now, I don't know if part of that reason was simply because there wasn't enough processing to do it. You know, this is very much lower than we've got on the STM32F4s, 180 megs on them, 256 of RAM, 1 or 2 megabyte of storage, depending on what one you had. So this may have had some limits. But it is interesting, and it's been a fantastic autopilot, to be fair. It really, really has, and it's a massive shame to see them go. It really is. It doesn't mean, though, these stop working, because they continue to work, and we're going to plug one in now. I need a USB cable first. But they do still work, so for those who do own them, it's still a good autopilot. It still absolutely works as you would expect it to. This one, I actually drowned this in a plane crash, and it got very, very wet. If you look on the bottom of the board, you can actually see it. Can you see the corrosion around there? Now, I actually cleaned this one up, but that corrosion has come back since I cleaned it up. So it needs another clean up again, I think, that one. But yeah, overall, it's been a very good autopilot. So what we will do next is we'll hook it up and have a look for those who haven't seen the Vector software, because it's quite good. Okay, so taking a look at the software on this, I'm gonna pop myself. I'm gonna leave myself off a minute to walk you guys through this. Now, you've got the configuration here on the one side. You've got flight controller RC setup, OSD setup, and if you ever wonder where some of that OSD, like the Betaflight one, has been come from, it's very much like this. You know, Eagle Tree have been doing this for a very long time now. They really have. You've then got advanced OSD setup, and you've got multiple pages of OSD. You've then got the Eagle Eyes waypoint setup, because they did add waypoints to it in the end. And they also did some things like 3D gates as well. If I just turn on that. So you've got waypoint setup in there too. And then you've got accessory setup as well, if using the buzzer. And I've got the buzzer somewhere, actually, which was the alerter, which was a really good bit of kit, actually. If you come across the alerter, it would flash an LED and buzz if you crashed, and it was a really good bit of kit. So if we go under the Vector flight controller and setup, whilst everyone complains about Ardupilot being quite difficult, this really was very, very simple. You had your basic overview for your airframe, which you can change, and you can select your aircraft types. You've got your basic gains, which just worked out of the box for the most part. There was very little to do on one of these. You've then got your receiver status, receiver type, safety mode status for your failsafe, compass, and that really is the basics of it. You've got your RC configuration page, flight controller setup, and again, this is where you're able to set your speeds, your cruise speeds. Absolutely fantastic for flying wings. In fact, I'm probably going to put the Vector back into my flying wing, because it's perfect for that. Absolutely perfect. You've then got advanced flight controller setup, and this is where you've got a lot more on the main gains and where you can play with stuff. Compass and sensor setup. Again, what you want it to do. Safety and nav. And there was always some great features around this for the return to home and the features like that, like S-Bus. And the support, your factory reset, save your configuration. And then you have the OSD. You got the basic OSD setup where you would do all of what you wanted it to show. And it really did have a huge amount of information because it was coming straight from the autopilot. You can cycle through the OSD screen, so you can say, I want more screens. So what you can do is click on, you could click on an area and turn on a function for it, and then click on an area and turn on, if I take where's pack voltage? You can see pack voltage is there. We could move that to there if we wanted to, or move that to there. We'll move it down to there. So we had all of the options we would come to expect from an autopilot available to us. So, you know, it's fairly basic, straightforward, and just worked. And one of the big benefits was, ignore that, we don't want to do that, just how simple the main setup was. It really was. And it just made life very easy. You could put it in an aircraft, pretty much set it up, and it would fly great. And that was the best part about the Vector. It was a really good bit of kit like that. Now, that is it for this video. Hopefully you have found it interesting. If you have, please do hit the subscribe button on both channels. As I've said, there's a link to the other channel in the description of this video as well. It is very new and we are just building that one up. As I said, the dedicated live stream Sunday night, 10 PM UK, 5 PM Eastern time, as well as random live streams in the week. And this, the main channel, is generally used for pre-recorded content. Finally, if you'd like to support the channel, please do check out the links in the description as well. And please check out our Patreon page if you'd like to support us on a more regular basis.